The universe is a vast and ever-expanding tapestry, stretching out farther than the human mind can truly comprehend. Each year, we uncover more about its secrets, yet the more we learn, the more questions arise. Back in 1929, scientists made a discovery that fundamentally changed our understanding of existence. The very elements that form our bodies were born in the fiery cores of ancient stars. The iron in our blood, the calcium in our bones, and even the oxygen we breathe, all of it was forged billions of years ago in the heart of stars that exploded long before our sun was even born. By 1957, humanity began to grasp another profound truth: the night sky, filled with its countless stars, isn't just a source of wonder and beauty. It's a gateway to understanding the immense and sometimes terrifying power of the universe. Every twinkle, every constellation, and every patch of darkness hides a story, many of which we've yet to uncover. Even today, there's so much happening in the cosmos that we barely understand. We often find ourselves questioning the purpose of it all. Why are we here? Why do stars and planets exist? Could the universe have turned out differently? These profound questions keep scientists and philosophers pondering endlessly. Yet, while we're busy contemplating, extraordinary events are unfolding in the universe, events so colossal and so powerful that they remind us how small and fragile we truly are. One such event is currently unfolding with Betelgeuse, one of the most famous and awe-inspiring stars in our sky. For centuries, this red supergiant has captured the attention of astronomers and stargazers alike. But recently, something strange has been happening. Betelgeuse has started to behave erratically, trembling and pulsating in ways that suggest something extraordinary and possibly catastrophic is on the horizon. Betelgeuse isn't just any star. It's one of the largest stars ever observed, and its sheer size is enough to leave anyone in awe. Imagine this: if Betelgeuse were placed at the center of our solar system, it would completely engulf Mercury, Venus, Earth, Mars, and even Jupiter. Its outer layers would extend beyond the orbit of Saturn, leaving no trace of the inner planets. Compared to Betelgeuse, our Sun, a star that sustains all life on Earth, would seem like a mere pebble next to a towering mountain. But Betelgeuse's size isn't its only impressive trait. Its location is equally remarkable. Situated over 640 light-years away from Earth, Betelgeuse resides in the constellation Orion, where it shines as one of its brightest stars. To put that distance into perspective, light, the fastest thing in the universe, takes 640 years to travel from Betelgeuse to us. In other words, when we look at Betelgeuse, we're seeing it as it was 640 years ago. Traveling to this star with current technology would take over 12 million years, a journey so long that it far exceeds the entirety of human history. Despite its immense distance, Betelgeuse has been studied in great detail. Unlike many stars, which remain relatively stable for much of their lifetimes, Betelgeuse has always been a star of change. Its brightness fluctuates in cycles, dimming and brightening over periods ranging from a few weeks to several years. These fluctuations are caused by the star's outer layers expanding and contracting, a cosmic rhythm that has fascinated astronomers for centuries. However, in recent years, Betelgeuse has begun to act unusually. In February 2021, its brightness dropped to one of the lowest levels ever recorded. This sudden dimming was so unexpected that it sparked widespread speculation. Was Betelgeuse nearing the end of its life? Was it about to explode in a supernova? To understand what's happening to Betelgeuse, we need to dive into its nature as a red supergiant. Unlike our Sun, which is relatively small and stable, red supergiants like Betelgeuse are massive, volatile stars nearing the ends of their lives. For millions of years, Betelgeuse burned hydrogen in its core, fusing it into helium and releasing the energy that made it shine so brightly. But now, that hydrogen is nearly depleted, and the star has entered a new phase of its life cycle. As hydrogen fusion slows, Betelgeuse's core contracts under the immense force of gravity. This contraction heats the core to extreme temperatures, igniting the fusion of helium into heavier elements like carbon and oxygen. This process, known as helium burning, releases enormous amounts of energy. However, unlike the steady fusion of hydrogen, helium burning is highly irregular, causing bursts of energy that destabilize the star. These irregular bursts lead to dramatic changes in Betelgeuse's outer layers. The star expands and contracts in cycles, creating pulsations that we observe as changes in its brightness. But the pulsations are only part of the story. As Betelgeuse expands, it loses massive amounts of material through powerful stellar winds. These winds strip away the star's outer layers, reshaping it and altering its evolution. This constant shedding of material is a hallmark of red supergiants and plays a critical role in their eventual demise. Over time, the star's outer layers become increasingly unstable, and its pulsations grow more erratic. For Betelgeuse, these changes are signs that it's approaching the end of its life. To study these phenomena, astronomers use advanced tools and techniques. Photometry allows scientists to measure the light emitted by Betelgeuse over time, revealing patterns in its brightness fluctuations. Spectroscopy, meanwhile, breaks the star's light into its component wavelengths, providing insights into its temperature, composition, and motion. Together, these methods paint a detailed picture of Betelgeuse's behavior, helping us understand the processes unfolding within it. But observations alone aren't enough. To truly grasp what's happening, astrophysicists use powerful computer models to simulate Betelgeuse's internal dynamics. These models take into account everything from nuclear fusion and fluid motion to the complex interplay of gravity and radiation. By comparing these simulations with real-world data, scientists can make predictions about Betelgeuse's future, and the future of other stars like it. One of the most fascinating processes occurring within Betelgeuse is stellar convection. This phenomenon involves the movement of energy from the star's core to its surface. As hot material rises and cooler material sinks, convection currents form, creating a churning motion that redistributes energy. This process not only affects the star's internal balance but also contributes to the pulsations we observe from Earth. These pulsations are like the beating of a colossal cosmic heart, a rhythmic expansion and contraction that reflects the delicate balance of forces within the star. Gravity pulls the star inward, while the energy generated by nuclear fusion pushes outward. This constant tug-of-war creates cycles of brightness and dimness that make Betelgeuse one of the most dynamic stars in the sky. But these cycles won't last forever. As Betelgeuse continues to burn through its fuel, it will eventually reach a point where fusion can no longer sustain it. When that day comes, the star will collapse under its own gravity, triggering a supernova explosion of unimaginable power. For a brief moment, Betelgeuse will shine brighter than an entire galaxy, its light visible even during the day. This supernova will mark the end of Betelgeuse's life, but it will also herald the beginning of something new. The explosion will scatter elements like carbon, oxygen, and iron into space, seeding the cosmos with the building blocks of planets, life, and future stars. Until that day arrives, Betelgeuse offers us a rare glimpse into the life cycle of a massive star. Its pulsations, fluctuations, and dramatic changes provide valuable insights into the forces that shape our universe, reminding us of the incredible power and beauty of the cosmos.